The James Webb Space Telescope has captured a stunning image showing the frost giant in astonishing detail, the best seen in 30 years. But beyond its beauty, this image reveals the composition of Uranus and Neptune, composed mainly of tons of ice and frozen gases, such as methane, ammonia, and water. This new view gives us the opportunity to delve deeper into what lies beneath Neptune's blue surface, revealing mysteries that have been intriguing scientists for decades. In addition, by looking further out into the solar system, we can better understand the slowing down of the timescale for celestial bodies to meet and collide due to long orbital periods around the Sun. For more than 30 years, the only view we had of Neptune was an image captured by the Voyager 2 spacecraft in 1989. As its mission was not focused exclusively on this planet, but on exploring the entire solar system and eventually heading out into interstellar space. The launch of the James Webb Space Telescope in September 2022 marked a milestone in the history of Neptune exploration, providing the sharpest image of its rings in more than 3 decades and revealing the planet itself in a completely new way. Operating in the near-infrared range, the JWST offers us a unique perspective invisible to the human eye. This image reveals Neptune's richness in elements heavier than hydrogen and helium, and although the planet's darkness is due to methane gas that absorbs red and infrared light, high-altitude clouds composed of methane ice reflect sunlight, appearing bright and almost white in the image. Thanks to the advanced technique and higher resolution of the James Webb Space Telescope, we have obtained the first clear view of Neptune's thin ring system, which scientists suspect is composed of ice crystals. This revelation through the JWST image shows a thin, bright line encircling Neptune's equator, indicating the presence of powerful atmospheric circulations such as violent winds and storms on the planet's surface. In addition, this new view allows us to observe more clearly a previously known vortex at the South Pole, and for the first time reveals a continuous band of clouds enveloping Neptune at higher altitudes. These advances in observational technology allow scientists on Earth to use light filtering method to determine the composition of Neptune's gases and other structures. The study of the rings, first observed by Voyager 2, promises to provide exciting new insights into the composition of this distant ice giant. The JWST observations represent a milestone in Neptune's research for astronomers, especially considering the lack of funding for a dedicated probe to this planet. Today, the new JWST data offer a wealth of information revealing previously unknown details about Neptune, the most mysterious planet in the solar system. This icy giant orbiting the Sun at a staggering distance of 3 billion kilometers, it's the 8th planet in our solar system and the most distant since the reclassification of Pluto in 2006. Neptune is the 4th largest planet and the 3rd most massive planet, with a mass approximately 17 times that of Earth. Its primary composition of gases, liquids, and ice has earned it the official title of ice giant. Although its vibrant blue color is one of its most striking features, derived from the methane gas in its atmosphere, Neptune remains one of the least explored planets, with many mysteries to be discovered in its atmosphere and climate, including the enigmatic Great Dark Spot. The disappearance of the Great Dark Spot of Neptune reveals a significant difference between storms of Neptune and Jupiter. Unlike Jupiter's Great Red Spot, which has persisted for centuries, storms of Neptune are short-lived and may not last that long, but they are certainly powerful. Neptune is especially notable for its wind speed, which can reach up to 1,350 miles per hour, far exceeding the most powerful hurricanes on Earth. Meteorological processes on Neptune's surface continue to puzzle scientists, especially with regards to its weather. In 2018, researchers detected a huge storm in the north of the planet, which was larger than the entire American continent. It was expected to follow the usual southward trajectory towards the equator, where Neptune storms usually dissipate due to the Coriolis effect, a meteorological phenomenon caused by the planet's rotation that directs winds and forms storms. However, this storm defied the Coriolis effect and advanced southward, defying expectations. In 2020, the Hubble Space Telescope captured the astonishing image of the storm rotating in the opposite direction, northward, an unprecedented event that perplexed researchers. For nearly 30 years, Hubble has observed similar dark spots on Neptune, but this new behavior raises questions about whether these storms could be hiding in the deeper layers of the Neptunian atmosphere before re-emerging on the surface from time to time. The storm remains an ever-evolving enigma, and scientists have observed that it may split into smaller eddies as it weakens near the equator, although these eddies may be difficult to observe directly. This is due to a lack of data, but it is a strong possibility that the detachment of the storm contributed to the change in direction. Some scientists theorize another oddity. Unlike most dark storms, this one lacks the usual bright white stripe. Normally, winds carry methane gas into the high-pressure center of the storm, forming a giant mound of air where it cools and crystallizes into ice clouds. This is similar to the orographic cloud we see on Earth when moist air arises, cools, and condenses. We observed these white clouds on Neptune in 2019, but they disappeared in 2020. Could it be related to the storm phenomenon? Maybe yes, maybe no. Studying Neptune is difficult because of its great distance and constantly changing atmosphere. It is time for us to explore Neptune further, perhaps with a future mission similar to Cassini's Saturn dive. A probe could dive into Neptune's atmosphere, collecting crucial data. In addition, this mission could help in the search for the elusive planet X, which some scientists believe could exist beyond Neptune. Only time and advanced technology will tell us the truth about Triton, Neptune's largest moon. The stunning image of Neptune obtained by the James Webb Space Telescope may have piqued your curiosity about the greenish blue light in the background. Don't worry, it's not an alien beacon, it's Triton, Neptune's largest and brightest moon. Triton, about the size of our moon, stands out because of its greenish hue, reflecting the faint sunlight in its distant orbit. Unlike most moons, Triton has a smooth, icy surface with few craters. Its unusually elliptical orbit suggests that it may have been an errant Kuiper belt object, eventually captured by Neptune's gravity. Triton travels around Neptune in the opposite direction of the planet's rotation, suggesting dramatic events in its past. In addition, like Jupiter's Europa and Saturn's Enceladus, Triton shows signs of ice volcanic activity, suggesting the possibility of a subsurface ocean. Let me know what you think in the comments box, and if you liked the video, remember to like, subscribe, share to reach more people, and turn on the notification bell.